Hey guys, welcome back to AlgoYogi. We are doing binary search series, and our third last problem of binary search is maximum number of removable characters. Let's visit LeetCode and go through the description. So you are given two strings s and p, where p is a subsequence of s. I'm sure you know what subsequences are. You are also given a distinct zero indexed integer array removable containing a subset of indices of s. So those values are indices of s, and this is also a zero index base. You want to choose an integer k, which is basically in between 0 and the length of removable, such that, and you want to choose it the maximum k. I'm just telling you because I have read the description. Such that after removing k characters from s using first k indices in removable, first k indices, okay? You're not choosing random indices, you're choosing first k indices in removable, such that p is still a subsequence of s. So hold your horses. S is a string, p is a subsequence of that string. Now you have this array removable which contains indices of s, subset, not all the indices, subset, and these indices could be basically here and there. They're not like 0, 1, 2, 3. See, in this case you see these removable indices as 3, 1, 0. They are not in any order. Now you want to choose maximum k such that you remove every single characters in s, until that k. So if you're choosing k as, let's say, 1 is indexed this, so you want to remove 3 and 1 indices in s, and when you remove those, your p should still be a subsequence of s. Very clear, right? I know it's kind of confusing, but if you read it like carefully, you'll know. And I think it's really straightforward if you just don't overcomplicate, like when you're thinking it. It's really written really clearly. So more formally, you will mark the characters at s removable I for each basically values between 0 and k. Then remove all the marked characters and check if p is still a subsequence. We already just went through this. Now we need to return the maximum k. You can choose such that p is still a subsequence. Already we went through that and we understood that in details. Subsequence we already know. Let's understand that on paper, like what we really are trying to do. So I'm gonna switch the view here. So we have s, which is basically a string s, and it has some indices. So I'm gonna write those as well: 0, 1, 2, 3, 4, and 5. Then we have another string which is p, 0 and 1. Now we are told p is a subsequence of s. What does that mean? That means all the characters of p occur in s in the same order. How do you check that? So let's write a pseudocode for subsequence, checking subsequence. So is subsequence, and let's provide s and p to indices, basically to start two variables, I and j, and while I is less than len s and j is less than len p, what we want to do is we want to keep checking if si is not equals to pj. In that case we want to increment our I, and I want to basically continue. So the reason I'm continuing is otherwise I plus equals 1, j plus equals 1. Okay, let's understand why I'm doing that. So I'm just gonna quickly make it a little small so that we can see the entire code. Oh my god. Seriously? Never mind. I'm trying to basically just get its size. It's not helping me with that. But anyway, yeah, okay. This is really stupid though. It should be able to decrement the size. But anyway, we'll understand it like this. I'll just remove it later. So what I want to do here is I have my pointer I basically pointing in the beginning of S. This is all about how to check P is a subsequence of S, and this we will utilize that. And then we have J pointer pointing in the basically P, and we are incrementing these pointers, and once they are equal then you increment both of them, otherwise you keep incrementing just I. So what will happen is either of these condition will falsify, and once that happens you want to return if j is equals to length p. So you want to return j equals to length p. If this reached just end of this particular p's end, that means we have seen all the characters in p in S such that they occurred in this particular order, so we were able to see all of them, and now we just surpassed basically all the characters. Now we can just return if the length of j is now equals to the length of p, and that will basically verify if p is the subsequence of S. Now what's the real question here? Is the question is to check basically if p is the subsequence? No. The question is we want to choose maximum k from removable, and once we remove that we want to return the maximum k such that after removing these characters from these particular indices, and we are able to basically also verify that p is still a subsequence of S. That is what we are going to return, but checking a subsequence is still part of our algorithm. So now how about when k is equals to 1? That means we want to remove third index and then check if p is still a subsequence of S. So what do we do? And that means if I'm choosing basically this 0 index, that means I'm removing until that index, right? Everything until that index. So choosing 0 index and k equals to 1 as a value, I'm saying as a value, but index is 0, 1 and 2. Now I will remove third indices right from here and check if this is still my if p is still my subsequence of S. It is, because you can check this value present over here, right? How about if I need to return maximum k? So I need to, again, linearly I'm checking. How about if I increment my k now? So how about when k is equals to 2? That means I want to remove 3 and 1. So what is 3? 3 was a, right? I want to remove this one, and I want to remove 1b. Is p still a subsequence of S? Yes, it is, because you can see a is present on 0th index and b is still, there is another duplicate of b which is like on the 5th index. So yes, this basically the maximum k, that is still is valid if we choose to remove basically until second value, which means k index is equal to 1. That covers these two values. So when I'm choosing a k, that means in removable array, until that index, including that index, I am basically taking all the indexes right from the beginning, removing all those indices in S, and after that I'm checking if P is still a subsequence of S. So we will write a helper function for checking if P is a subsequence of S, and then linearly we go k from one by one, and then basically creating like a set from these removable array, and keep checking that if these, either we have removed these or they are equals to all the characters here, and we keep checking if after removing those characters were we able to see P's character, all of them in same order, to check the subsequence of S. So we will do that, but the thing is that's not the optimal solution. We will now this is binary search series, so we will apply a binary search here. How do we do that? So you can already tell that we were trying to find this maximum k linearly. We will utilize binary search to find this k by basically having left and right pointer over here. So let me clean it up for you. By the way, in previous case when we were like trying to figure this k's max k value, like if we choose 2 as index, then if we remove this a and we also remove 3, if I'm trying to choose k as 3, then this will not be possible. We'll not be able to verify that this is P is still a subsequence of S. That will not be true. So that will not be true. So what I'm gonna do is I'm gonna just tell you how we will be applying binary search here. So what we were doing is we were linearly trying to check the right k in this way. So rather than doing that, we will have left and right pointers on removable array, and then we'll have a set called removed set, which will basically hold the values that we are choosing when we are calculating the mid. So if I'm calculating the mid here, so on these indexes 0, 1, 2, the mid would be 1. I'm choosing this particular value here. So if I'm choosing this, that means I will add 3 and 1 to my removed set. That means I have removed all of these, and after removing these, all the indexes from my S, is my P still subset of subsequence of S? Subset is a different thing, sorry about that. Is P still a subsequence of S? If it is, then you basically assign your result this value mid, basically mid plus 1, because we are trying to the mid is a calculated index, and k is basically how many characters. So because index starts at 0, so 0 and 1, those two values could be included as removable characters. That represents k, so I'll store that into my result, which in this case would be 2. Okay, so mid plus 1. And then because this is now represents an index until where if we remove all of these, my P is still a subsequence of S, then I want to basically check more values because I'm trying to return maximum k. So what I'll do is I will increment my left pointer to mid plus 1, and then check if there are some values in the right side that will still justify all my conditions. And that will basically, if we were doing linearly, the time complexity would be if we were doing the linear approach with brute force. So I'm gonna just say brute force, oh my god, brute force would have been a time complexity of big of let's say this is n, so max of n or m, like I'm just gonna call it n into max k, this value. But now this binary search approach will bring down the time complexity to n will remain same, because this is about checking if P is a subsequence of S. That will remain same, but k could be really big. That is why this will this solution will bring down the time complexity a lot when we are basically having log k rather than k. Okay, so now let's just write down our optimized solution, straightforward. And I'm gonna switch the view. Let's make it look a little nicer, and then let's write down the first thing first. How about we write the helper function first, which is checking is subsequence. I am going to have two values. First is let's say s, and second would be let's call it subsequence. So I'm going to call it subsequence. I just want to, I don't want to call it p, because we will be you know what, I think we could call it p. Yeah, we could call it p as well. So let's call it p. Let's call it p. So I and j, which will be 0 and 0, these both represent the starting index of s and p. Then we have our while loop. While I is less than length s, and j is less than length p. Okay, so we keep going. Now we want to check if si is either it's not equal to pj, or I'm going to define this removed set, and we will basically assign more values here. These are the values that have been removed in s. So the condition would be either this I from s because it has been removed, and these removed values will be chosen when we decide some k value. So until k, everything in the beginning from removable has been removed, those indices from s. So either s in removed, this will be accessible, by the way, in Python, like it works like that. Either s is in removed, or these two values are not equal. That means what? Let's increment our I by 1 and then continue to check, basically, like it will go back here after incrementing it, so that it can check the next value if next character from s is equal to p, because at the end of the day we want to try to get to the end of p, and this will basically come out of here, either from here or here. Either it didn't find all the characters, or it did find and it became equal to the length of p. I hope you're understanding. If you have been coding for a while, like I'm sure you're following me. Or you can just increment I and j, right? I and j, because that means they both were equal. Now you want to increment them nicely. Now what do? We will return if j is equals to length p. Okay, I'm gonna just write it a little neatly so that looks a little nice. Now removed set. Before removed set, let's have our left and right pointers. These will come from the length of right pointer will come from removable, and let's choose proper index. Okay, so basically these left pointers and right pointers are pointing to the removable endpoints. Now we want to basically start our while loop while checking if L is less than basic binary search algorithm, finding the mid. You already know that, left and right divided by 2. All right, now what we want to do is we want to check. Let's have, I think the best place for removed is over here. I'm gonna have this over here, because now this removed set will contain all the characters that have been removed until m. M is this value. I'm choosing choosing k value over here. Okay, so I'm gonna assign here removable array until basically m plus 1, because otherwise it will exclude m. Okay, Python thing. Okay, now what do? We want to check is subsequence true of, let's send in s and let's send in p. If this is true, that means we were able to choose this mid that we just found out. That could be my result. Initially, let's have result as 0, and then have result as m plus 1, and try to find a bigger m or bigger k. That will happen if we choose the next window. Basically, when we are dividing one array into two equal parts, then the mid works. How about let's take the left pointer to mid plus 1, so that we could find another bigger mid that still works. If it doesn't, still we have our answer. Okay, so mid plus 1. Otherwise, I will have right pointer bring down, because this particular thing did not work. That means we need to bring it down, because after removing that many characters like this, p was not a subsequence. Basically, we removed like too much characters, and it became a situation where like p was no longer a subsequence of s. So what do we do here? Mid minus 1. Otherwise, we just return our result. Okay, choosing k value, choosing max k value. I think that's better, right? Okay, so let me zoom out and see if we are doing everything right here. I think this is good, right? Length s, length p. If the character is not equal, so increment s character index to check the next character if it is equal to p's character. Otherwise, increment both of them, check. So this function is pretty good. This function is pretty good. So I'm gonna just, I think let it expand. Now this also looks pretty good, because we are assigning m plus 1. Since you remember from the conceptual part, m is an index, but we return the values, like how many values you can remove, which is k. So let's try to run it on examples, and works with examples. I'm gonna submit it, and hopefully this will work. And yes, it does. I'm gonna write down time complexity. Oh my gosh, it took so long. Might be like one of the longest videos. That will be n into log k, or this n could be maximum from these characters, or this n is like a combined value of these two. At the end of the day, is s that we are covering. S will be larger, so it's n is where, oh my god, where n is the length of s. Okay, space complexity would be constant 1. This is done. You guys can have a nicer look. I'm gonna mark this done and see you guys later in the next problem. We have 2 more problems to go, and after that we'll be starting dynamic programming. Until then, bye bye. See you guys later.